All right, so thank you so much and welcome back again with our next video. So in this video, I will be going to also make sure to discuss all about the another operation in terms of insertion that deals with the graph, the same thing, and that will be going to focus in the adjacency of matrix. So what if you will begin to insert using the adjacency matrix? Now, so let's define that one first. The adding of vertex in the graph using the matrix. To add vertex in the graph, we need to increase both the row and your column of the existing adjacency matrix and then initialize the new elements related to that vertex to 0. So that means to say, class, if, for example, if you will add F right now in your node A, say for example, since they don't have any relationship as right now, so what you will do is you will add that in your matrix. So since your matrix is A to E, so you will just add the row and another column in that certain manner. Now let's try to check that one. How does it work then? So this one here for the vertex insertion in terms of undirected graph, we'll try to see that one. So suppose that your goal is insertion of F at node D. So what if you will insert F at node D? So since that is undirected, so it won't matter if that is F to D or D to F. So that is simply how does it work. So F to D, and then in your adjacency matrix, this will be the representation of your adjacency matrix. And if you don't know how to do that, that was in the previous video. You can just refer that there so that I will not be going to repeat myself another time. Now, for adding that in your, for inserting for F, since you will insert that in your another path, and F was not being implemented that right here. So what you can do, you will just insert another row and another column, and you will just update the direction of DF and FD. So DF, since that is adjacent as right now, that will be equals to 1. And F and D as well. So F and D, that must be equals to 1 as well, and the rest will become 0. So let's try to see that in here. Suppose that we already inserted F at node D, so that won't matter if the direction will be put to D to F or F to D. So your matrix right now will be updated 0 as what I mentioned if they are not adjacent, and 1 here and 1 here. Then that's how it works. So that is actually so simple or basic for the adjacency matrix of the for that particular adjacency. So now let's move on to the next one. We'll be talking to the directed graph. So for the directed graph, you will also make sure to do it in here. So suppose that you do have this graph right now and you want to insert the node F at node B. So node B is here and your direction will be B to F. So that means to say from B, node B, where you will create a out order of out order arrow, so that will point to F. So from node from vertex F, it will be ingoing from node B. So suppose in your adjacency matrix will be this one. So you can just refer how to get the adjacency matrix in the previous video, the same thing. And the representation in here, you will just add F, column and rows. And for that one, since your direction is B to F, so your B to F alone will be updated into 1. Your F to B, you will not update that one since, of course, that is, they don't have any relationship. It will not go vice versa in directed graph as for that one. So suppose that we already inserted here the node B, node F at node B, and you will just update as what I mentioned in your node B to F direction. So that's how you will do that. Make sure to really understand how does it work. And thank you so much. And for the next video, I will also make sure to discuss pertaining to the deletion operation already from edge deletion of adjacency list. Thank you so much. And that's it for today.